Okay, so in this video, we're going to take a look here at statlearning.com. It's a really nice resource. It provides you with both a free complementary text, very comprehensive, in R and in Python. And if we just take a quick look at the textbook that's available here and we go into the overview, you can see the breakdown of themes. So all the standard techniques like linear regression, classification, resampling, all the way out to multiple testing. So really very, very comprehensive. And the textbooks are, they're it's a complete analysis. These are proper textbooks written at a very high professional level. I found easy to track and a tremendous resource if you're using heavily resources like Kaggle or just jumping between GitHubs. Sometimes you would like a body of knowledge organized under a single overarching structure, and you get that all here. Now, in addition to those textbooks that are free, right, there's also a range of resources linked to GitHubs and so on, notes, so slides. So if you're in the area and you're teaching, right, if you're involved in data analysis or economics or accounting, any of those fields, and you have to provide students with a set of organized, structured classes, you have a set of slides there which are really very useful. You have the data sets that are used, and also very importantly, you have the files, the Python files are available as well. So that really adds a huge amount of functionality. So if we come to our ISLR with Python, and then look at our the notebook files on GitHub, and come down to the various sections, you can see the chapter titles correspond to the textbook. Right now, if we just go to the authors, maybe I give them a little bit of credit, and I have their names here. Yeah, Gareth James, Daniela Witten, Trevor Hastie, Robert Tibshirani, and Jonathan Taylor. And if you look up Stanford Online, there's some YouTube clips there available that also track through each of the various chapters in a very sequential, organized fashion. And they're done in a very light-hearted fashion, easy to view, not at all intimidating, and quite intuitive. So nearly at all levels, they've really thought about how to put in place a learning resource that gives you full set of resources, going from the data to the code in R, code in Python, a free textbook, paralleled in R and Python, and the online YouTube clips are there as well. So really a nice resource. I'm just going to take a look here at the GitHub for Python, and I'm just going to demonstrate a little bit the functionality available. So important for many fields, accounting, finance, data journalism. Very often we have to, medicine, very often we have to predict an outcome, and the outcome can be binary. And we're looking at, is there evidence of disease or not, for instance? And you have to make a call on it and predict a 1-0 type outcome. And in chapter 4 here, which is the chapter based on classification, there's quite a nice overview of a topic, an implementation of classification techniques based on stock market prices. So it's kind of quite relevant then to people who are financial practitioners. And what they try to do here is they take data stock price data, so returns data, and they use the lag. So these are daily observations, and then they use the lags. These are daily lags, so returns, and they use the returns, the daily returns, to predict the direction of the stock. So if the stock price is going up, then the return is positive. So you can see here today is a positive. So these are ups, but if the return is negative, the stock price is going down. So if you like, we can bifurcate into an up, down, or a 0, 1. So it's a binary type outcome. It's a classification type problem if we set up the direction as the target variable or the dependent variable. Okay, so how would we piggyback on the material set out here? If we're in the GitHub and we have the URL, just copy and then go over to Google Colab. And if you don't have, so to access Google Colab, set up a Google account, just a Gmail account, and you incidentally then get access to a drive, and you can also access Collaboratory. And I'll leave a video clip explaining that. So I've gone into Google Collaboratory just in the Chrome browser. Then I come across to the GitHub tab. We don't need these. I don't have a GitHub account. And I paste in, if we look at the URL here, I've copied that URL. And then I go over to here and just paste in the link. And it should be able to find that link. So what's happened here is I've now taken the code that's available here and I've pasted in. And a sensible thing to do, if this is work you're trying to edit a little bit, touch up, tweak, save your own copy in your Google Drive. So if you want to save your copy of your version of this Python notebook, no problem. And a convention I generally use is just put the date in so that it provides me with a timeline, and I kind of sense I can easily track then at what point something was done. Okay, and save, right? Now, we'll try to implement here and see what happens, but it's quite likely that we'll have to do a pip install, or at least I had to before. So when we were importing the usual libraries, NumPy, Pandas, Matplotlib, stats model, we ran, like there's no issue, but when I did it before, I ran into the same problem here. So to resolve that, just do a pip install IS, and I'll keep the capitals, ISLP. So basically the authors have set up a Python library where the data has been made available in that library. But in order to access the library, you would run a pip install, and then you can call in data. Normally, if we're uploading a CSV file to get the data in to perform some kind of analysis, I have to go over to the folders and then get into the content folder and then upload the data directly from my machine. Or I can read in through a URL. If I've pandas, I can do a pandas read URL type command. But because there's a package that we've installed here with all the data included already, we just need to do a pip install, and I'll restart the runtime because it's prompted me to do that. Now, if that's done, it is, I can just come back here and run the libraries one more time, and should be able to import in without any. So all those libraries have come in, and then we're going to invoke ISLP commands to perform a confusion table. sklearn, which is a fairly standard machine learning package available in Python, and then a number of different models: naive Bayes, k-nearest neighbor, scaling capability, test train split, and logistic regression. Okay, so normally if we were to load in data from S markets, if we hadn't have installed ISLP, the data wouldn't come in. But now we can read directly in. We can create an object called S market and bring it in from the data available in the ISLP package, right? So we've installed it so that we get the data as well. So that really makes this process streamlined, and we don't have to go searching around getting data. And if you're in a lecture, if you're in a class and you're trying to demonstrate this, where you may not have accessed all your personal directories, this certainly kind of speeds up the process, and it's all available then in the cloud. Okay, so what are the headings then on the columns? Well, we have year, and then lag 1 is the return yesterday, lag 2, 2 days ago, the return 3 days ago, 4 days ago, 5 days ago. And then we have the direction, which is either up or down. Is the return positive? Then it's up. If the return is negative, then we're going down. So we're trying, what we've done here then, if you like, we've created a classification problem, and we want to predict, can we use the lags, the daily returns, to predict whether the stock price will go up with 5 days, 5 lags, 5 preceding days, right? So it's a kind of a useful exercise. It's an exercise that practitioners in finance would be interested in. We can do a correlation matrix here. That'll be fairly standard. So we run a correlation matrix. We can see in the diagonal, we're getting ones, off diagonals, we're getting correlations, and they're duplicated. So the correlation between lag 1 and let's say lag 2 is this negative 0.0264, but then the complement, or the lag of 2 correlated with lag of 1 is going to yield the same result. So that's why when we go beyond the diagonal, we're getting results that match, right? Okay, so nothing unusual there. And then the volume is the volume of trading in the stock. What I like about this resource is that I'm getting quite a bit of detail and explanation, but also if I go back then into the textbook and go to classification and then come down to the lab session here, all the bits that we're touching are being explained with a textbook. So all the different steps that we'll run through are being explained step by step by step. So that's a really nice way to organize learning. And we can replicate. This is really, the gold standard here is reproducibility, and we definitely can reproduce the results. So that's really positive. And then we want to set up a logistic regression, and we're going to drop today direction and year. And then that creates our x's, and then our y, or our dependent variable, is whether the stock went up or down. So we're using the lags in effect. We're dropping today, direction, and year, but including the lags and volume. And then under y, the target variable is the binary outcome. Did the stock price go up or down? And when we execute here, we get these parameterizations. And if we want to just summarize the parameters, the values obtained are the same as what we have here. And if you look at the p-values, they're all well in excess of 0.05. So, we're struggling here in terms of statistical significance. the standard error is quite big relative to the actual coefficients. So the z values are, high, but the p values are not sufficiently low. Um, uh, we cannot rule out the possibility. So, for instance, there's a 60% chance intercept is 0, and a 14% chance that the lag uh, here is 0, and there's a 39% chance that lag 2, the parameter on lag 2, is 0. So they're all way too high for us to, really accept as being statistically significant. So that already is an issue here. And, we can go through the implementation and look at the p-values, try to, look the likewise, we can use the p-values attribute to access the p-values for the coefficients. And then we could predict our model. And so, if we predict, the predictions we're getting here in the first 10 rows are all close to 0.5, which is kind of, if they're all like that, it means we're marginally predicting up or marginally predicting down. We might be getting strong signals. So the model may be a little weak here. And then if we run the confusion matrix and get the overall level of accuracy, so we run the confusion matrix and the true positives, and true negatives are on the diagonal here, but we're getting a large amount of error off diagonal. And when we sum all of the 4 up here, we would get 1,250. There's 1,250 days of data. When we sum the on diagonal values, which are where we correctly predict the market's direction, the sum of these two divided by 1,250 is 52%. I'll just check that. I mean, what that is suggesting that we don't have any predictive power in our model. The model is like a coin flip. Okay, now so there's a fairly good overview here with textbook treatment, and that's hugely beneficial. And the next step here is to apply these other techniques and in machine learning. I'll just jump across to one other GitHub that I like a lot, and that's if I can Aldo Deck. Maybe I'll just make a reference. Aldo Deck does something similar, but in a more intuitive way. I suspect he was sort of inspired to some degree by the ISLP artifact. There's definitely similarities. If we go to the repositories and look for his notebook on machine learning for finance, which is a little bit down here. In my case, if I open that one up and take a look at his model here, machine learning in financial markets. And again, usual thing, we copy the URL and then I go in to Google Colab, and in the browser, in the Chrome browser, signed in with my Gmail, I go to GitHub. Don't have a GitHub account, it's not a problem. I paste in the URL for Aldo Dector. We search for it, it'll bring in here machine learning. Okay, my usual approach here is I try to save a copy onto my own Google Drive. And I typically will date that because it gives me a sense of timeline, right? So I can trace back when something was done. Now he does something similar, right? So he imports the pandas libraries, but instead of taking the data from ISLP, which wasn't around in the original machine learning, if we look at the history here, he would have set this up, I think, July 23rd, 2019. So this preceded the Python version of ISLR. But if I go in here and that looks okay. Now, sometimes you might, but it doesn't seem to be any issues, but sometimes you might have to do a pip install Y Finance if there are issues arising, right? So I suspect we don't need to do it because no issues have emerged. But later on, if there is, maybe we'll try that. Okay, so I'll just put that in for completeness. I won't execute because it'll take a bit of time. Now, what's going on here? Exactly the same approach really as set out in the ISLP textbook, right? So it's the same approach. We've turned, we have a classification problem and we're trying to classify if the stock price goes up or the stock price goes down, and we're going to predict that on the basis of preceding 5 days or 4 days of daily returns. So like 1, like 2, like 3, like 4, like 5, and I think volume is included as well here. But in the AldoDeck version of this, we do the same libraries. We're going to use sklearn as the machine learning. We won't reveal the parameters of the logistic regression model. That'll happen in the background. And then we run the model. So the start date is 2010, January 1st. And we're going to call in the ticker for Apple. So we're going to go to Yahoo Finance portal, pull the data for Apple, the Apple stock, and get its daily observations for the period 2010 up to the start date is 2010. If I don't add in anything else, it'll bring me up to today. So that'll be 20. Today is the September 7th, 2023. Okay, so we're going to get slightly different results here compared to AldoDeck because our end date is not going to default to 2019, July 23rd, but actually our current date is the 7th of the 9th. It's September 7th, 2023. So we have 4 years more data here. Okay, anyway, let's just try out and see what happens. So I'm going to bring in the data, and the data is the same. So the data that we have here is actually the same as the data that AldoDeck has. It's just because this is the head is the same, but the tail would be quite different, right? Because it would be more recent data. And in terms of what lag 1, lag 2, lag 3, lag 4 represents, it's today's stock price divided by yesterday's stock price minus 1. And then lag 1 is yesterday's return. Lag 2 is the day before yesterday's return. Lag 3 is the day before's return, and so on. And we're using 4 lags here, not 5. And we're dropping any rows where we have missing values. Okay, so we start from, although the start date was the 1st, we drop a few days because of the return. When we estimate the returns, it would have created missing values. Okay, and then we look at the direction, or we take the today column, and then we convert that into series of 1. So we take direction, the today's value, right? And if the value is greater, if the return is greater than 0, it's 1. If the return is less than 0, it's 0. If the return is negative, then we get 0. If the return is positive, we get a 1. And so we apply that to direction. And then today you can see when today's values are negative, it's 0. So we're creating this new column. But when today's values are positive returns, we get a 1. And that's still true. And we still have the same dates here. because we've just lengthened the sample. And then we define the independent variables and the target variable. So we set up our x's as lag 1, lag 2, lag 3, lag 4, no lag 5, no volume. And then we're going to do a test train split, but we're using 2019. So in the original data set, we would have went to July 23rd, 2019. So we would have only a small amount of test data. Here we'll have substantially more, right? So if we run a regression, right, and we predict, so we use the sklearn model to run this regression. So we're using these to predict the y's, and then print out, we make a prediction using the sklearn command and the model, and then we get the output for the logistic regression model. If we look at the confusion matrix here, what we note is that the accuracy, if we were to do that basic analysis, take the 21 plus the 5 to 5 plus 30 plus 602. Then we have, there was 1,178 values here in the test data, right? In the test data. And if we, number of rows in the test data, if we take the sum of 21 plus 602 and divide by 1,178. So if I take the sum of, so again, set it up, 21 plus 602. So they're the on-diagonal values in the confusion matrix are those that are true positives, true negatives, so they've been correctly predicted. And divide by the overall number of rows in the test data, we get an accuracy level of 53. Now, in the original Aldo Dector notebook, it was 58, but you can see our value here is consistent with the accuracy level from the logistic regression output. What this tends to reveal here is that the accuracy of the model, that the logistic regression is no better than a coin flip. So 53% level of accuracy is actually quite poor, and then that would suggest go off and get a better model. And if we go further down here, you can see how he introduced further enhancements and tried different things. But in fact, as he progresses through, he was finding that the accuracy level wasn't improving much. And so even with hyper-tuning and all the rest, there isn't really any dramatic increase. He got up to 61% accuracy. But the reality here should be when we find results like that, if we know, if we have some background in finance, we might be aware of the phenomenon of efficient markets. Markets generally are not that easy to predict. If there were, people would just make easy money, which doesn't seem likely, right? We assume in finance there's no free lunches. And so it shouldn't be so simple that we could take the historical daily returns and predict the direction of the market the following day. If we could do that, it means we would have a money machine. So it's not a problem with the models here that we're getting low accuracy. It's more an issue around the data that we're working with. Because markets are efficient, any predictability normally in the information, the stock price, is probably going to be already taken into account. And so that's already been priced in. And so what we're getting in terms of stock prices are really random shocks, which is more consistent with a Viner. Okay, one other small point I would make. So you see the book has been actually quite influential in terms of triggering other sort of an ecosystem of GitHubs and so on. But if you want a complete overview with a sort of, a very comprehensive, robust treatment, you can go back to the textbook. One, there is a GitHub from Jungya Wu, sorry for mispronouncing, and they developed a few years ago the Python version of ISLR. And again, if you go into their linear regression model, sorry, it should have been classification. If you go into the classification model, here you can see they do something similar. And so again, you could go through the same steps here of implementing. So a lot of people, in fact, have tried to emulate the work of ISLR, but in Python. And the classification notebook chapter 4 is available here, and just different touches, slight innovations, slight different tweaks, but all very interesting and very useful if you're trying to build up your analysis. So we can see here, in this instance, we have ROC curves, and again, we can see there's low predictability from the lags for predicting the direction of the market. One other GitHub that I liked, if I can bring it up here, is Jay Warman. He has quite a few, and he has a Coursera course. And we go into the repositories, ISLR Python. Okay, let's open that one up. If we come down to the notebooks, and again, chapter 4 was the classification chapter. Again, you'll find there's another version. So default data, which follows actually more in line with the book. So he or she replicates what's available in the textbook. These are all diagrams that were in the textbook, but manages to replicate here in Python, which is nice. So again, it's default on credit cards, and there's a complete treatment there, but it parallels with the textbook. So if we go back to the textbook, that area is touched on in the classification. These graphs were already explained. And again, that's why it's not just the really tremendous resource that ISLR and ISLP represent in their own right. It's the sort of excitement in the community of Pythonistas and so on, and data scientists that they created, that there's other ecosystems with other people's rendering of the material touched. And so I think the big contribution here made by the authors is really that the extent to which they provided under a single overarching framework some really nice resources, very useful, and a place you can go back and check some of the technical detail in a textbook type description. The authors also very credible figures with series credentials and big profiles, so that these people, you can take what's written in their textbook as having some degree of authority, right? The explanation they provide, which is not intimidating at all, are explanations that are coming from people who are experts in the field. So again, I draw attention to their contribution. Okay. So in that regard, I'm going to leave there and let people explore themselves.